So let's start with the one question. So force of 2.8 Newton is applied on a block. The force of friction between block and okay, okay, and one more thing. Okay, this is block is 2 kg. Okay, so this block is 2 kg. Acceleration due to gravity is 10 meter per second square, and coefficient of friction is 0.4. So force of 2.8 Newton is applied on the block. Let's say we have applied force of 2.8 Newton. So basically find out the force of friction between block and floor. So we have to find out this force of friction. Mm, block and floor. So as we know that first we what we do is we find out the normal reaction. So since 2 kg is the mass of this block, therefore mg, that is 2 into 10, that is 20 Newton normal. Basically 20 Newton weight is acting downward. Therefore 20 Newton normal reaction is there, and the limiting frictional force, we know that we calculate limiting frictional force F limiting, uh, that is equal to mu n. So it is here, mu is 0.4, n is 20. So limiting frictional force is 8 Newton. So when someone applied force of 2.8 Newton on this block, which is not enough to overcome this 8 Newton force, the block will not move, and the frictional force here in this case will be is equal to the applied force just to balance the applied force. So it will be 2.8 Newton. Is it clear, like limiting frictional force? And I think Harini was not there in last class. So have you studied this before? Okay, okay, fine. So we'll see the next question. So the frictional force of the air on a body of mass 0.25 kg. The frictional force of the air on a body of mass 0.25 kg falling with an acceleration of 9.2, 9.2 meter per second square will be. And acceleration due to gravity is, let's say, 10 meter per second square. Okay. So there is a body which is falling under gravity, and it is having acceleration of 9.2 meter per second square. Okay. And the mass of this body is 0.25 kg. So ideally speaking, if there is, so basically they are asking how much is the frictional force acting on this body because of air. Okay. So of course, when something falls in this air, it experiences frictional force because of air, and it is generally known as drag. Okay, so this is basically a frictional force experienced by this body because of air. So ideally, if this body falls down under the acceleration due to gravity, then its acceleration should be equal to g, that is 10 meter per second square. And but here in this case, the acceleration of this body is 9.2 meter per second square because it is falling under, it is experiencing mm, frictional force. So to calculate like how much is the frictional force experienced by this body, we can draw simply free body diagram. Let's say, so there is a 0.25 kg into 10, so that is 2.5 Newton weight of this body acting downwards, and it is having acceleration of 9.2 meter per second square. However, mm, if you see, there is, if it is, since it is falling downwards, there is a frictional force, let's say F, acting upwards. Okay, so using Newton's second law, we know that net forces acting on it equal to mass into acceleration. So net forces, since the body is falling down under gravity and acceleration is also in same direction, we will consider forces acting downwards as positive and forces acting upward as negative. Okay. So therefore, in this case, what we will get is net forces will be 2.5 Newton, that is weight of this body, minus F, because it is acting upward, is equal to ma. So m here is 0.25 and a is 9.2. Okay, so f will be 2.5 minus 0.25 into 9.2. So that is the value of frictional force. So it will be basically 0. If you take 0.25 common, it will be 10 minus 9.2. So it will be zero point 0.8 into 0.25, that is 0.2 Newton. Is it clear till now? Okay. Harini, okay. Okay, fine. So let's see now what will happen if like there is one block on floor, it's lying on floor, and other block is uh hanging. Okay. So let's say there is a pulley. Okay. It is connected with a string to two masses. Let's say this is M1, this is M2. Acceleration due to gravity is G, and coefficient of friction between this mass M1 and the ground is, let's say, mu. So in this case, like if you, means there will be many cases. Okay. So first case, let's say if this system is not moving. Okay. So this system is not moving. So in this case, if it is not moving, if you consider the free body diagram of this mass 2, let's say mass 2, it is, since it is not moving, let's say T is the tension, of course, T is the tension in this string. So, and M2G will be the weight acting downwards. So T will be equal to M2G. Okay. And in this case it is not moving. Okay. And now if you see the free body diagram of M1, This T is the tension, which is equal to M2G, which is trying to pull it rightwards. Therefore, there will be friction, which will act in opposite direction. So here M1G is the weight acting downward. Therefore, M1G is basically normal reaction upward, and therefore, okay. So since this in this case, uh, the block is not moving, the frictional force in this case will be equal to M2G, which is equal to applied force. Okay. However, if this block M1 is on the verge of moving, okay, it is about to move. So applied force T or tension T is, if it is enough for it to just start the motion, then frictional force will be equal to limiting friction in that case. So frictional force will be equal to limiting friction, and it will be mu m1 into g. Okay. So if this, okay, so now if we equate these two things, so this tension T uh, is basically almost enough to start the motion of this block. So let's say M2G is slightly greater, a very slightly greater or greater than equal to mu M1G. So GG will get cancelled. So in this case, or in this case, basically we got this. But if you see it from other end, like what is the value of limiting friction? The limiting friction is here mu M1G. Okay. And until it is greater than or equal to M2G, this block will not move. So until mu is greater than M2 upon M1, this block will not move. And as soon as mu become lesser than this M2 by M1, this block will start moving. Any doubt? Okay. So we'll see one question now. A rope lies on a table such that a part of it hangs down the table. A rope lies on table such that a part of it hangs down the table. When the length of the hanging part is L and length of part of the and the length of the part and the length of rope lying on table. Okay. So or which is on table is P. So the coefficient of friction between the rope and table. Why? Sorry. Rope and table. If rope just begin to slide. So we have a table. Okay. So there is a rope lying on the table. Let's say this is the rope. So this length which is lying on this table is, let's say, P, whereas this length which is hanging is, they have given as L. So find out the coefficient of friction mu, which will be enough, or for which the rope will just start sliding. For which rope just start sliding. Can you try this question? I will wait for 2 minutes. Please try to solve this. I will wait for 2 minutes. Otherwise, I will solve. Okay. Okay. Harini, any answer from your side? Yeah, it is correct. Mm. It should be greater than or equal to L by P. Okay. Next question is also similar. Uh, so, but slightly tricky. Okay. A rope lies on a table such that a part of it hangs down the table when the length of the hanging part is one third of the entire length. One third of the entire length of rope. The rope just began to slide. So the coefficient of friction will be. So here also means they have given same question. So here they have given a rope. Let's say this is the hanging part. So mm, the length of hanging part is one third of the entire length of the rope. So if let's say L is total length of rope. So this length of this hanging part here is L by 3. So the remaining length is 2L by 3. Okay. So here in earlier question you have seen that when the rope will start sliding, it will be basically greater than or equal to hanging part divided by uh, non-hanging part or remaining part. So it will be less. Therefore, mu should be greater than or equal to 0.5. Okay. So that will be the answer. It was a similar question. Okay. A heavy uniform chain lies on horizontal tabletop. If coefficient of friction between chain and table, so coefficient of friction mu is 0.25. then the maximum friction of length of the chain that can, okay, so the maximum, okay, so basically we have to find out maximum length of chain, basically maximum percentage length of chain that can hang over edge, okay, without motion, without moving, okay, it should not start moving. So what is the maximum percentage of length? So it is options are 20%, B 25%, C 35%, and D 15%. Okay, this is also easy question. I will just give 1 minute. Please try to solve this within a minute. Okay. Okay, you got 20 percentage. Vaibhav. Okay, okay, fine. Okay. So again, it is same question only. So let's say this chain is, let's say this is the ground. Okay. There is a hanging part. So if this length is, let's say, L1, this length is, let's say, L2. So we know that if it is about to start moving, then mu is basically equal to L by L2 by L1. Okay. So here mu is given as 0.25. So it is equal to L2 by L1. So L2 is 0.25 times L1. And so, so total length, let's say L is total length, which is equal to L1 plus L2. So basically we have to find out L, like what is the length hanging with respect to total length. So let's put L1 is equal to, since L2 is equal to 0.25 times L1, L1 will be equal to L2 by 0.25. So it is basically 4 times L2. So here we got 4 times L2 plus L2 is equal to L. So L is equal to 5 times L2. So L2 here is L upon 5, which is 0.2 times L. So this is basically 20%. Okay, so option is A. You got this? Okay. So next question. A coefficient of static friction between block A of mass 2 kg and the table is zero point 0.2. Okay. So so let's say there is arrangement. Mm, this is block B. This is block A. The coefficient of friction between block A and this ground is basically given as zero point 0.2. Okay. And mass of block A is 2 kg. So here we have to find out mass of block B, for which these two blocks won't move. And acceleration due to gravity is 10 uh, meter per second square. So options are 2 kg, B is 4 kg, C is 0.2 kg, and D is 0.4 kg. So here also we can apply same concept. So this basically we have to find out maximum mass of B for which this system will not move. So so it will be like when this block A, since block A is like is not moving because of friction. So unless the force applied won't overcome the limiting friction, block A will not move. So we just have to the applied, when the applied force is equal to limiting friction. If it is more than a limiting friction, then only block A will move. So let's equate limiting friction with uh, let's say tension in the string. So if you take block A here, it is having 2 kg mass. So since G is given as 10, 20 Newton weight is acting in the downward direction, and there is normal reaction of 20 Newton. So the limiting friction is, since mu is given here as zero point 0.2, limiting friction is zero point 0.2 into 20, that is 4 Newton. So 4 Newton is the maximum load or tension that can be present where this block will not move. So now if you consider the FBD of block B, there is tension 4 Newton, there is mg weight acting downwards, and since it is not moving, we can equate both. So 4 is equal to mb into g. So 4 is equal to mb into 10. So mass of block B is basically equal to 0.4 kg. Any doubt till now? Harini, any doubt? Okay. So till now we have seen that the system was not moving, or it was on the verge of moving. Okay, so we used to find out limiting friction. So now let's see if what will happen if it is moving. Okay, so again we have two masses, M1 and M2, attached with a string. So since there is a string involved, there is a tension T in the string, and this whole system basically is moving with, let's say, acceleration A, and mu is the coefficient of friction between block M1 and surface. So in this case, what will be the tension and what will be the acceleration of the system? Okay, so we have to find out that. So now if you like, now if you see this as a whole system, net force acting will be, one is M2 into G. So like weight of M2 acting downwards. So that is one of the force, that is M2G. And then there is a force of friction which is opposing the motion of M1. Okay, so let's find the weight of M1, that is M1G is acting downward. So there is normal reaction, M1G upward. Therefore, the force of friction is mu M1 into G acting, or it is opposing the motion. So net force acting on this system is M2G minus mm, mu times M1G. The net mass of the system is equal to m1 plus m2. So acceleration is basically force upon mass. So it can be calculated as m2g minus mu m1 into g divided by m1 plus m2. So this is the acceleration of this system. And if we have to find out tension, so let's consider the free body diagram of mass 2. So again, we will consider mass 2 here. So M2G, weight acting downwards, tension T in the string, and A is the acceleration of the system. So now since the object is moving downwards, so we'll consider forces in downward direction as positive. Net forces is basically m2 in g minus tension T, and that is equal to m2 into acceleration of the system. So tension T is basically m2 into g minus a. So now if we substitute the value of a acceleration, what we got above here, so we will get T is equal to tension T is equal to m2 into g minus, in bracket, we'll put acceleration, so it is m2 g minus mu m1 g divided by m1 plus m2. We can take g outside, so what we will get, T is equal to m2 g into, so we will multiply the left hand side by, multiply and divide the left hand side by m1 plus m2. So after that we will get common denominator, so m1 plus m2 minus, so g has gone, so it is m2, and minus minus plus mu m1, so divide by m1 plus m2. So m2 m2 will get cancelled. We will get, we can take m1 as common. So what finally we will get is T is equal to m1 m2 into g divided by m1 plus m2 into 1 plus mu. Is it clear? Okay. So let's take one example. Okay. So there is a system for mass m1 is basically 20 kg, coefficient of friction is 0.1, and there is another mass of 100 kg. Okay, so find out. So of course there will be tension in this string, and there will be some acceleration. So find out tension T and acceleration A. Can you solve this? I will give you 2 minutes to solve this. It is based on previous derivation, and I think it is better to solve it like from basics instead of remembering those formulas. So I will wait for 2 minutes. Please try to answer it. Okay, both of you have got the answers. Just I will try. Okay. Yeah, I think that is correct. 183. Okay. So I will solve it just to show. Mm, 8.16 is the correct answer. Okay. So now let's say now we know first what we do in this case is we find out net force acting on the system. So there is weight of this 100 kg block acting downwards, that is 100 into 10. So that is equal to 1000 Newton. And then there is frictional force acting here. So they since this block is 20 kg, there is weight of 200 Newton acting downwards. Therefore, there is a normal reaction of 200 Newton acting upwards. So if we see the frictional force, it is 20 Newton, that is mu n. So it is 20 Newton acting towards left. So net force acting will be 1000 minus 20, that is 980 Newton. So 980 is basically mass of the system. Mass of the system is 120 into acceleration. So acceleration will be equal to 980 by 120. So 12 eights are 96. Okay. So then you remain with 20. Then there is a 1. Then again, it is basically 8.1 and there will be more digits, meter per second square. And if we have to find out tension, so if for finding out tension, just take this 100 kg block. So there is force tension T acting upward, weight of 100 into 10, that is 1000 Newton, 1000 Newton acting downwards, and acceleration is A. So since it is moving downward, forces acting in downward direction are positive. So let's say 1000 minus T, that is equal to MA. So M here is 100 into acceleration is, let's say, 8.1. So tension will be equal to 1000 minus uh, some 81. Okay. So it will be around 920. Okay, 1 second, I think. I hope I have not done any mistake. Just 1 second, okay? Okay, okay. It is 8.1. So 1000 minus 8.1 is like 810. Okay. So it should be around 190 Newton. And if you take more digit in this 8.1, it will change slightly. Okay. You got the answer? Like, is it clear? Okay. So next question is like PYQ and slightly challenging. So a system consists of three masses. A system consists of three masses M1, M2, and M3, connected by a string passing over a pulley P. By a string passing over a pulley P. The mass M1 hangs freely and M2 and M3 are on rough horizontal table. Okay. The mass M1 is free and M2 and M3 are on the rough horizontal table. with coefficient of friction mu. Okay. The pulley is frictionless and negligible mass. So pulley is not involved in this thing. So the downward acceleration of mass m1 is. So find out downward acceleration of mass m1, and they have given m1 is equal to m2 is equal to m3 is equal to m. Okay, so just for distinction, so they have a system. Let's say this is pulley P, which is not involved in this problem. There is a mass m2, there is again one more mass m3, and m1 is hanging. Okay, and coefficient of friction is mu for both the cases. It is mu only. Okay, so the options are: A is g into 1 minus g into mu divided by 9. B is 2g mu by 3. C is g into 1 minus 2 mu divided by 3. And option D is g into 1 minus 2 mu divided by 2. So just try to solve this question and type A, B, C, D. Which one do you think it is correct answer? Then I will give an attempt. Okay. So this is one of the PYQ, and mm, please try to solve this question. Okay, you got C. Okay, I think both of you got the correct answer. Yeah, C is the correct answer. Okay, so next question is slightly tougher than this question. Okay, do you want me to solve this or I can proceed with next question? Okay, I will proceed with next question. The force required to just move a body up inclined plane is double the force required just to prevent the body from sliding down the plane. The force required to just move a body up inclined plane is double the force required just to prevent the body from sliding down the plane. And mu is the coefficient of friction. So, and mu is coefficient of friction. So just the question is find out relation between mu and theta. Okay, and theta is inclination of plane. So let's say you have some inclined plane which is making angle theta with horizontal. There is a body of mass m kg here. So you need, if you want to push it upward, or then you need force of 2F to just push it upward. And if you want to stop it, since it is on plane, this body will start moving downward. So if you have to stop this downward motion, then you need to apply force F, okay, so that it will be, it won't come downwards in this case. So there are two possible cases they have given. So we have to find out relation between, and mu is the coefficient of friction in both the cases, relation between mu and theta. Have you understood this question? Vaibhav, what about you? Have you understood what they are asking exactly? Okay. So just try to attempt this question. This is like, yeah, this is I think one of the most challenging question. So just you have to find out the relation between mu and theta here. So I will give you 3 minutes to solve this question, and then I will give the solution. Okay. Okay, theta is tan inverse of 3 mu. Okay, I think both of you got it correct only. So I will just try to solve this. So in first case, it will start moving upward when you applied force. Let's say it is 2F. Okay, 2 times the. Mm, so since let's say this is the mass, so if this is the mass, there is a component of weight which will act downward, that is mg sine theta. There is one normal reaction, mg cos theta. So it is common in both the case. In first case, you have applied force 2F and it will start moving upward. So therefore friction will act downward and it will be equal to mu mg cos theta. So basically 2F is equal to mg sin theta plus mu mg cos theta. In second case, let's see, everything will be same. You have applied force F upward, but this object is about to move downwards. So therefore, the direction of friction will be upward. Okay, frictional force. So in this case, F will be equal to mg sin theta minus mu mg cos theta. Now, if you multiply equation, let's say this is equation number 1, this is equation number 2. So if you multiply equation number 2 with 2, then it will become 2f equal to 2mg sin theta minus 2 mu mg cos theta. Now, if we subtract equation 2 from equation 1, then it will get cancelled, you will get 0. mg sin theta minus 2mg sin theta will give you minus mg sin theta, and mu mg cos theta minus 2 mu mg cos theta will give you plus 3 mu mg cos theta. So mg will get cancelled first. So sin theta will be equal to 3 mu cos theta. So tan theta is basically sin upon cos is tan theta. Tan theta is equal to 3 mu. So mu or theta is equal to basically tan inverse of 3 mu. So both are correct answers. Okay, I think both of you have done it correctly. Okay, so we'll meet after 15 minutes, around 6:45. Okay, we'll take a small break. So we'll see the next question. So a conveyor belt is moving at a constant speed of 2 meter per second. A box is gently dropped on it. The coefficient of friction between them is 0.5. The distance that box will move relative to belt before coming to rest is. Okay. So in previous chapters, like we have seen the motion with constant acceleration. So we have seen three equations. First is V is equal to U plus AT. Second is V square is equal to U square plus 2A into S. And third one was S is equal to UT plus half AT square. Okay. So these equations are valid for motion with constant acceleration. Okay, so from Newton's second law, what we have seen, F is equal to ma. So mass is constant. Generally, mass is constant, and if force is also constant, then acceleration is also constant, and therefore we can use these equations. Okay, so when there is when you will see that when there is only frictional force is acting on object. So in that case, these equations you can use, okay, equations for motion with constant acceleration. So now they have given us that conveyor belt is moving at constant speed of 2 meter per second and the box is gently dropped on it. The coefficient of friction is 0.5. Okay, so let's say this is a conveyor belt which is moving maybe at 2 meter per second and you have dropped a box, okay, which is of mass. Okay, the mass of the box is not given, let's say. Okay, and it is dropped and coefficient of friction between this block and conveyor is 0.5. Okay, mu is 0.5 here. So you can reverse this case also, like if now if you since the relative motion, like now this object box initially is at rest and conveyor belt is moving. Okay, so when you will put it over the uh, conveyor belt, when you will put this box on conveyor belt, it will have relative velocity of 2 meter per second in uh, what in opposite direction to the motion of this conveyor belt. Okay, or you can simply consider that this conveyor belt is basically became stationary and now this object is or this mass is moving with velocity 2 meter per second towards left and coefficient of friction is given as mu is 0.5 in this case. So in this case, uh, only the force which is acting on this block will be frictional force and that will act in a direction opposite to its motion. So let's say mg is its weight acting downwards. The normal reaction is also mg, and therefore the frictional force is mu mg. Okay, so force acting on this block is mu mg in rightward direction. So if force is given, mass is known, so acceleration is can be calculated as force upon mass. So it will become mu mg divided by m. So it will be equal to mu into g. So mu g is the acceleration of the object in opposite direction. So it is basically, so if you consider the acceleration or velocity in this direction as positive and this direction as negative, and if you apply the equation of motion, that is v is equal to u plus 80. So here they are asking us to find out in how much time it will come to the rest. So it will come to the rest means acceleration is zero. Sorry, velocity, final velocity is zero. Initial velocity is 2 meter per second plus here since acceleration is in negative direction, it is minus mu g into t. So basically time is equal to 2 upon mu g. So it is equal to 2 upon mu is 0.5 in this case and g is let's say 10. So it is equal to 0.4 second. So in 0.4 second, the object will come to the rest relative to the conveyor belt. Is it clear? Okay. We will move to the next question. A block B is pushed momentarily along a horizontal surface with an initial velocity v. A block B is pushed momentarily along a horizontal surface with an initial velocity v. If mu is coefficient of sliding friction, so block B will come to rest after how much time? Okay. Question is block B will come to rest after how much time? So the options are G mu by V, B is G upon V, C is V upon G, D is V upon G into mu. Okay. So there is, let's say this is ground, this is a block B. So block B is pushed for a moment and it has achieved velocity V. Okay, initial velocity is V and mu is the coefficient of friction. So can you find out the timing? Take 1 minute and try to solve this question. Take 1 minute and try to solve and then otherwise I will solve. Okay. Option D. Mm, okay, so we'll just see. So you can simply apply. So B is okay. Object is B. Weight is acting downward. Mg. Normal reaction acting upward. Mg. So frictional force acting is mu mg. So acceleration is basically mu mg by m. So it is mu g in opposite direction. So we know that v is equal to u plus at. In this case, final velocity is 0. Initial velocity is v plus a. So a is here minus mu g because it is in opposite direction into t. So basically t is equal to v upon mu g. Okay. So option D is correct. Next question is, consider a car moving along a straight horizontal road. With a speed of 72 km per hour. If the coefficient of static friction, okay, is mu, so if mu is equal to 0.5, the shortest distance in which the car can be stopped is the shortest distance in which the car can be stopped is how much? Okay, g is given as 10 meter per second square. So options are 30, 40, 30 meter, 40 meter, C is 72 meter, and D is 20 meter. Okay, so take 1 minute and try to solve this. I think this is also similar and easier question. Are you solving? Okay. Answer 180. Okay, just 1 minute. Okay. So the velocity, basically, car is moving with 72 kilometer per hour. So 72 kilometer per hour. So 72, 1 kilometer is 1000 meters. So 1000 meter divided by hour is 3600 seconds. Okay. So these two zero will cut with these two zeros. 72 by 36 is 2. So it is basically 20 meter per seconds. So it is moving on horizontal road. Mu, okay, V is equal to U plus 80. So finally it will come to rest 0. U is 20 plus 80. So T is equal to basically 20 by A. Okay. And of course the acceleration will be negative in this case because so acceleration is basically mu G. So mu here is 0.5 into 10. So it is 5 meter per second. Sorry, 0.5. Okay, give me 1 second. Okay. If mu is zero point 0.5, acceleration is okay. Force upon 0.5 into 10 is basically 5 meter per second square. So acceleration, I think, uh, okay, if mu is 0.5, then acceleration will be 5 meter per second square. So t will be okay, t will be equal to 20 upon 5, that is 4 seconds. So this vehicle will stop after 4 seconds. So now we can use other equation also, s equal to ut plus half 80 square. So initial velocity is 20 meter per second into 4 seconds plus half into, of course, acceleration is negative here, minus 5 into t square is 4 square. So it will be 80 plus uh, 20. It will be minus 100 by 2. So it will become 30 meters. You understood? Like like how we got it 30? Hello? Okay, 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 fine. We'll see next question. A given object takes a given object takes n times as much time to slide down, n times as much time to slide down as perfectly smooth 45-degree. Okay, sorry. So slide down 45-degree rough incline, 45-degree rough incline as it takes to slide down a smooth, okay, okay, to the smooth. The coefficient of friction between the object and incline, okay, find mu. So basically, there are two planes, okay, both are making angle 45-degree with horizontal. First one is, let's say there is object. First one is rough with coefficient of friction is mu. Second one is, let's say it is smooth surface, okay. Smooth means basically mu is 0, okay. Coefficient of friction is 0. So time taken in first case, this, let's say this is the first case, this is the second case. Time taken in first case is t, and time taken in second case is, let's say, okay, it is t1, and in second case let's say t2. So t1 is basically 5 times, oh sorry, not 5 times, n times t2. So find out mu. Okay, we have to find out the value of mu. So now if you see, so both the like both in both the cases, object has to travel same distance only, okay. So in first case, let's say m is the ob mass of this object, let's, and it is having uh, some velocity. Hmm, it is having some velocity v, initial velocity, let's say v, and it is sliding down the plane. So in this case, so there will be frictional force that will act on the object. So that will be, since mg sine theta is the component of force, so mu mg sine theta will be acting, sorry, one second. So here normal reaction, if let's say this angle is theta, so normal reaction is mg cos theta. So mu mg cos theta will be uh, acting as a friction, and mg sine theta is basically the force acting on which is uh, basically mg sine theta is the force or component of weight acting on this object, okay, in this case. So if you find out the net force acting on this, then it will become mg sine theta minus mu mg cos theta, and therefore the acceleration will be, we will divide it by m, so it will become g sine theta minus mu g cos theta. So this will be the acceleration in this case, okay. So now if you have to find out the how much, first of all you can find out till what point it will move. So we know that v is equal to u plus at. So or let's say, mm, okay, so in both the cases, uh, it will travel the same distance, okay. So first, in second case, it is taking time n times the first one. So let's find out how much time it will take to travel in first case. So we'll use second. Let's use the other formula. S is equal to ut plus half at square. And let's assume that initial velocity is u is 0. Okay. So t is basically equal to 2s upon a, square root of 2s upon a. So it will be equal to 2s divided by a is here g sine theta minus mu g cos theta. Similarly, if you consider second case, so in second case there is no friction, okay? So it is a smooth surface. So if this is the block M, then there is a force acting downward is mg sine theta, component of weight basically. So net force is mg cos sine theta in the direction of motion, and mass of course is m. So acceleration will become g sine theta. So again, if you use same formula, S is equal to ut plus half at square, and u is 0. So S will become, or t here, t will again become root of 2s upon a, where in this case acceleration is uh, here. So this one was t1 for first case. This is t2. So t2 will become 2s upon g sine theta. Okay. Now we have the relation that t1 is equal to n times t2. So now if you put t1 and t2, or if you take square on both sides, it will become t1 square is n square into t2 square. So 2s upon g sine theta minus mu g cos theta is equal to n square into 2s upon g sine theta. Okay. Now 2s will get cancelled with each other. G will get cancelled from denominator of all both sides. So what we will get is 1 upon sine theta minus mu cos theta is equal to n square upon sine theta. Or okay, huh. Now let's take this n square on left hand side and this sine theta minus mu cos theta on the right hand side. So what we'll get is 1 upon n square is equal to sine theta minus mu cos theta divided by sine theta. So finally you will get 1 upon n square is equal to 1 minus mu upon tan theta. Okay. So mu upon tan theta is 1 minus 1 upon n square. So finally what equation you got is mu is equal to 1 minus 1 upon n square into tan theta. So this is like one of the important equation. You can remember this. Like if they give you two cases, in first cases they give there is object which is sliding and there is a rough surface, so there is some frictional value, let's say 0.2 or 0.3. And in second case, let's say it is smooth and those are the mu is 0 basically in this case. So if they give you two cases and time taken by this object to reach is like two times that of smooth surface or three times that, like basically it is n times that of smooth surface it is given, then you can find the coefficient of friction using this formula, that is 1 minus 1 upon n square into tan theta. So in our case they have given theta is equal to 45, so tan 45 is 1, so therefore mu is equal to 1 minus 1 upon n square. Have you understood this part? Okay, so there was one question on this concept. So you can directly solve it using formula also, or you can again derive everything. So the question was, starting from rest, A body slides down a 45-degree inclined plane in twice the time it takes to slide down same distance. In absence of friction. The coefficient of friction between body and inclined plane is, question is, the coefficient of friction between body and inclined plane is. So you can directly use above formula, that is mu is equal to 1 upon 1 minus n square tan theta, and here they have given 2 times, time taken is equal to 2 times, so n is equal to 2 and theta is 45, so tan 45 is equal to 1. So mu is equal to 1 minus 1 upon 2 square is 4 into 1, so it is basically 3 by 4, which is 0.75. You have you understood? Okay, so we'll see one last concept in friction. So now if we have two blocks, okay, let's say this block is m1 having mass m1, this block is having mass m2. There is coefficient of friction mu, and you have applied, let's say, force. So when you apply force on this block, of course there will be friction that will, like m1 will experience friction in this direction opposite to the direction of applied force, whereas if you apply frictional force on m1 in left hand side, there will be frictional force on m2 in right hand side. Okay, so how does this work? Okay, so l- let's say you have mass. Ideally what we see, ideally we see that if this is the force, so norm weight of m1 acting downward is mu, sorry, m1g. Okay, m1g is normal reaction. Okay, so this limiting frictional force will become mu into m1g. So if mu m1g is the limiting frictional force, and if this f is more than that, then mu into m1g will act downward, and so this body will move with mu m1g. Okay, force. So what exactly happens is, like, let's say if you have mass of upper body is, let's say, 5 kg, let's say mu is 0.1 kg, and this body is 10 kg, and you have applied force of 10 newton on upper body, and g is 10 meter per second square. So in this case what happens is, mm, if the force applied by you is, like, if it is less than limiting friction value. Okay, so let's see, in this case normal reaction for on 5 kg will be, uh, since 5 kg is the mass, 50 newton will be its weight, so 50 newton is the normal reaction. So limiting friction will be 5 Newton. Okay, let's consider mu is equal to zero point 0.4. Okay. So limiting friction will be 20 Newton. Okay. So it is uh, so ideally it is not crossing the limiting friction value. So what we generally assume is uh, uh, force frictional force of, let's say, F is acting on this 5 kg, and similar frictional force F is acting on this 10 kg object. So in this case, this 10 Newton is less than the limiting frictional force. So what generally we assume is there is a frictional force F between 5 kg and 10 kg, and the motive of this frictional force is basically to stop the relative motion between 5 kg block and 10 kg block. Okay. So now, to find out the value of this frictional force, what we do is we solve miss if it is like, since this frictional force F, since the applied force F, which is 10 Newton, is less than limiting frictional force, we consider that both the 5 kg and 10 kg block will move with each other. So this is basically applied force, net applied force is 10 Newton on this system, and net mass is 15 kg. So the acceleration of the system will be force upon mass. Okay. And similarly, if you only consider this 10 kg block, there is force F, that is frictional force, is acting on it, and its mass is there. And since both whole system and 10 kg block has the same uh, acceleration, so acceleration of this 10 kg block is basically F upon 10. So since acceleration of system and 10 kg block will be same because both will move together, you can equate 10 upon 15 is equal to F upon 10. So you will get F is equal to 100 upon 15, and that will be the frictional force acting between these two blocks. So in what we have considered in this first case, when this applied force is greater than is greater than or sorry is less than the limiting frictional force, is less than limiting frictional force, then in this case both 5 kg block and 10 kg block will move with each other, and it means there the frictional force F is not equal to applied force in this case. Okay, because you apply 10 Newton force, then there is a frictional force acting on this 5 kg block. Similarly, 10 kg frictional force is acting on this uh, equivalent frictional force is acting on this 10 kg block. Whereas if you see the case now, again if you see the case, this is 5 kg, this is 10 kg, and you have applied force of 100 Newton, and mu is again, let's say, zero point 0.4. So mu is zero point 0.4. So normal reaction of 5 kg block is 50 Newton because G is 10. Normal reaction is 50. So frictional force, limiting frictional force is 50 into zero point 0.4, that is 20 Newton. So since this applied force is more than limiting frictional force, both block will move with a different acceleration. So in this case, the acceleration of both the block will be different. So 5 kg, so here the frictional force which will act is limiting friction because the applied force is more than that, that is 20 Newton, and therefore 20 Newton force will act on this 10 kg block also. So if you consider now 5 kg block, net force, there is a 100 Newton acting in right side, right direction, and 20 Newton in left direction. Net force is 80 Newton, and mass is 5 kg, so acceleration is, now in this case both the block will move in with different accelerations. Okay, when applied force is more than limiting friction, so acceleration will be force upon mass, so it will be 80 upon 5, that will be 16 meter per second square. Whereas for 10 kg block, there is frictional force only which is acting in right side direction of 20 Newton. So its acceleration will be 20 upon 10. It will be 2 meter per second square. So now I will take one more example, two more example. Let's see. Let's see, we have a block. Let's say we have two blocks. This one is having 10 kg, bottom one is like 40 kg, and applied force is, let's say, 50 newtons. And in this case, the coefficient of friction between two blocks is 0.4. So first thing what we will do is we will find limiting frictional value. So 10 kg block is sitting on 40 kg block. So there is normal react, basically weight of 10 kg block that will act downward. It will be 10 into acceleration due to gravity 10, that is 100 Newton. So limiting frictional is basically mu into normal reaction. So normal reaction is 100 Newton, mu is 0.4. So limiting frictional force is 40 Newton. Uh, okay, this is 5 Newton, okay, not 50 Newton. Now the applied force of 5 Newton is less than limiting frictional force. So now in this case, there is a frictional force acting in opposite direction for 10 kg block and frictional force of F acting in this direction for 40 kg block. So this whole system will move together in this case because applied force is less than the limiting frictional force. So now we know that net force applied is 5 Newton and total mass of the system is 50 kg. So acceleration is 5 upon 50 for whole system. And you can consider this 40 kg block separately. So if you consider this 40 kg block separately, then the applied force on 40 kg block is F and its mass is 40 kg. So its acceleration is F upon 40. And since both are system is moving, both are moving like at same acceleration, 5 by 50 is equal to F upon 40. So you will get F is equal to 4 Newton. So that will be the frictional force that will act in between them. Okay, because acceleration of both will be same. Whereas in second case, similarly, if you have 10 kg block and downward is 40 kg block, and now you have applied 50 Newton force. So in this case also, limiting frictional force will be 40 Newton, and you have applied force more than 40 Newton. So in this case, frictional force that will act will be 40 Newton on both the block. Okay, only the difference is their direction. So now if you consider 10 kg block, net force of 10 Newton is acting, and total mass of this is 10 kg. So it will move with acceleration 1 meter per second square. Whereas, okay, so here we have found out like uh, both the blocks are moving at same acceleration only. In this case also, mm, so there is 40 kg block and frictional force is 40 Newton. So it will move with acceleration 1 meter per second square. But like when the applied force F is more than the limiting frictional force, the both block will move in opposite direction. Like if it was 45 Newton instead of 40 Newton, let's say it was 45 Newton, then the net force that was acting on this block will be 5 Newton. So it will move with acceleration 0.5 meter per second square, whereas this block will experience same acceleration because frictional force is constant of 40 Newton. Okay. Do you have any doubt in this like two block system? Okay.